This is lesson 1.4, order of operations with rational numbers. This is the last lesson of our chapter 1. So hopefully you remember BEDMAS and you've worked with this before. BEDMAS stands for brackets, exponents, division, multiplication, addition, subtraction. And this acronym is used to know the order of operations when there are many different operations in a problem. So this section also combines everything we've learned so far in the chapter. So addition, subtraction, multiplication, division of rational numbers in either fraction or decimal form. And now we can have multiple of these operations happening in the same question. So let's review each part of BEDMAS. Brackets can either be round or square, or if there's some information underneath the square root, this is also treated like a bracket. So if we have this question here, you would solve or simplify what's in that bracket first before doing anything else. And same thing here, if we have the exact same problem, except it's a square root instead, simplify what's under that square root first, and then do the rest of the question. Exponents are next. Reminder, these are the tiny numbers on the top of another number. So common ones that you might hear is when a number is being squared or cubed. So here we've got 4 squared. When you have that tiny number here, it means it's multiplying by itself that many times. So 4 by 4 gives us 16. If it's to the power of 3, that means it's multiplying by itself 3 times. This is an example of to the power of 5, so it's multiplying by itself 5 times, but we won't see this as often. Most of the ones you see will be to the power of 2 or to the power of 3. Here's a list of the perfect squares that you don't need to memorize. It's a good idea to have a lot of them down, but you should know all of these multiplication tables and just keep an eye out for these perfect squares. What I mean by perfect squares are like 25 is a perfect square because it can be square rooted. 25 is one number times itself, which happens to be 5. So a perfect square can be square rooted. So how do we take the square root of a decimal? We know how to take the square root of a whole number. If it was root 16, we know that that's going to give us 4. But what happens when we have decimals? Well, it actually works out pretty well. If you take the square root of 0.16, it just gives you 0.4. And we know that's true because the square root of 16 is 4. So you can essentially ignore the beginning part of the decimal and ignore the beginning part of the decimal here. And then it's already a problem that we know how to solve. Another example, the square root of 1.39 is going to be 1.3 because the square root of 139 is 13. So if you ever are unsure of what the square root of a decimal number is, try to ignore the decimal number and then see if you know the square root of what remains. And then of course, you'll notice that the decimal for each is in the exact same spot. So after the first one or after the first 0. Those just have to match. Another example, the square root of 6.25 is going to be 2.5 because the square root of 625 is 25. And I think those are examples in some of the homework, so it might be good to have that reviewed. Similar idea when we're taking the square root of a fraction. So the square root of 1 over 16 is just 1 over 4 because the square root of 1 is 1, the square root of 16 is 4. So it's almost like you take the square root of just whatever's on the top, and then you also take the square root of whatever's on the bottom, and that is what you're left with. We'll do a lot more work with exponents a couple chapters later, but we still need to know the basics when we're working with order of operations. Same thing here, square root of 1 over 25 would give you 1 over 5. So you want to make sure that you always do brackets first and then you do exponents. And if you have a square root, you want to do that right at the beginning as well. Then we would move on to division and multiplication. So you do the D and the M from BEDMAS. You do this in the order that they appear. So you don't necessarily do all the division first and then all the multiplication first. For all division and multiplication, just do them in the order that they appear from left to right. So in this example, we've got a multiplication here and a division here. We start with the multiplication, not with the division, because the multiplication appears first. For this example and for many examples, it actually doesn't matter which one you do first. You end up with the same answer. But I have an important note here that although sometimes the order you do it in doesn't matter, and you'll get the same answer regardless, sometimes it does matter. And so it's hard to know which time it's going to matter for. So that's why we just always go from left to right when we're doing division or multiplication. Addition and subtraction is the same thing. That's going to be the last part that you do. And you also do the addition or the subtraction in order that they appear from. So even if subtraction appears before addition, you're going to do that first because it appears first. So then let's just do this one practice question together, and then you can practice in the workbook for more. So first, brackets. Do we see any brackets? No, but we do see this square root. And remember, we're going to treat square roots like a bracket and deal with whatever's underneath that square root first. So that's where we're going to start. So what is under the square root? 0.9 plus 0.7. So this is practicing adding our rational numbers in decimal form. This is going to give us 0.16 because 0.9 plus 0.7 is going to give you 0.16. So that's done. The rest is going to stay the same. Okay. Now we still have the square root, so we've simplified what's underneath it, but now we actually have to solve it. So thankfully, this number works out nicely. We've already talked about the square root of 0.16 is going to give us 0.4 because the square root of 16 is 4. Okay, we're done the bracket, we're done exponents. Next moves on to division and multiplication. And we do this in the order it appears. So the first one, oh, sorry, we're not done that yet. We have the exponents to deal with first because we have two sets of exponents right here. So yes, we dealt with the square root, but we have these exponents to deal with before any multiplication or division. This stays the same. What is 4 to the power of 2? That's going to give us 16. And 3 to the power of 2 gives us 9. There we go. So now we're done with our brackets. We're done with our exponents. We move to division and multiplication. This will be the first piece that we do because it's the multiplication or division that shows up first. So then we've got 16 times 9. What is 16 times 9? We can do that on the side. We've got 54. And then 9 plus 5 gives us 14. So that gives us, we've got negative, because this negative is out front. We've got minus 144. And then we've got the divided by 12 is still there. Now we have our last piece of division before we move to the addition and subtraction. This works nicely. We've got 144 divided by 12. That gives us 12. So we've got a minus, because we continue that minus down, 12. Almost done. Now we just do our addition and subtraction in the order that it appears. So we've got this first, negative 0.75 plus 0.4. So that's going to still be negative overall, but we move right on the number line. So negative 0.75, that's going to give us negative 0.35 if we add 0.4 to it. We still have our 12. Then our final step is we subtract these together. Thankfully, it's an easy one. We've got minus 12.35 as our final answer. So it's critical that you follow all of these operations in order. See, I almost forgot the exponents when I was doing it. You've got to make sure you do it in order because otherwise your answer is going to be different. So that's the end of our chapter 1 lessons.